Hello everybody, welcome back to Automata Grammars and Computability. Today we are going to be talking about regex. This lecture is a little bit special in the context of the class because normally we talk about theory, but regex, the way that we describe it today, will actually show a little bit of programming. Recall that we can denote a regular language using a diagram of an NFA or DFA, set notation because a language is a set of strings, a regular grammar, which we'll talk about later, and the regex notation, which is used in many programs. And today, of course, we'll talk about that regex. You might wonder, is there a difference between what I'm calling regex and regular expressions? Sort of. I might use these two phrases interchangeably. Normally, what I mean is that the regular expressions that we've been seeing work like they do in theory, but regex, as it works in programming, looks a little bit different syntactically. So there is a small difference, and hopefully it should be clear from context which kind of thing I'm talking about, whether I'm talking about regular expressions as in theory or regex as you might program them. Regex as a tool has been around since at least the 70s. And one thing I'm going to say a couple times is how it's used in programming. This slide is mostly just to give you a sense of what these command line utilities could possibly look like. And I know they don't make sense yet, but they should become clearer as we go through the slides. So I do want to remind you, regex is a big part of programming. In particular, regex is a big part of Unix. For example, text editors allow regexes for search and replace. You might use text editors like VI, Ed, or Emacs. You can also use regex in the command line with awk, TCL, and Perl, or if you're making shell scripts. Languages, programming languages, so things like the repython package, you can do it in JavaScript. If you know Java, things like scanner and string split are also using regular expressions or regex under the hood. And then, since I did say it was a big part of Unix, Unix or Linux or Mac shell commands, if you pull up your command line, you can use sed, find, grep, egrep, and fgrep. And not to mention compilers. I point this out specifically. When you write Java code, it does compile, and that compiler does use some sort of parsing with regex to be able to compile your code. And the way that people use these command line tools or in their programming, normally it's because they're either debugging systems or they have some sort of log file that they want to parse and get some output out of, or determine if there's a pattern in there, and regex is an important tool for doing that. Now, all of these little regexes have different kinds of flavors, and you can do different things, and there's different syntax. So for today, what I want to talk about is regex as it looks in egrep. So the main idea with regex is to match patterns. I have two examples here. If you wanted to match a date with slashes, like 1/1/1970, you could do it like this with carets and backslashes and curly braces. We'll talk about that syntax in a moment. And you can match more complicated things. Email is notoriously difficult to match for some reason. It's unlikely that what I have here is actually correct, and there are probably some edge cases of types of valid email addresses that it misses. But nevertheless, this is the point of regex. Regex describes a pattern of text. And the reason that that's useful is you can test whether a particular string matches an expression's pattern, and you can use a regex to search and replace characters in a string. And as you may have noticed, it's very powerful but tough to read. And by the way, this example here should also match email addresses. You can actually see the @ sign here. But but there are definitely email addresses on which this fails. All right, so yet again, regular expressions for pattern matching. I want you to give it a try on your terminal. Let's say that you're in the command line. What happens if you type in ls star? Okay, good. And now I don't know what directory you're in or anything like that, but let's suppose that your directory has the files a.tex, bc.tex, a.dvi, and bc.dvi. What would happen if you typed in ls star.dvi? What would you see? Or what do you see if you happen to have those files? If you don't, you can also try this with a different file extension based on whatever directory you have. So one thing you might notice here is that star in Unix is a pattern that matches any string of symbols. So if you type in ls star, which is star is not necessary, but it means that it'll match any file name. If you type in something like lsstar.dvi, then you're going to see all the files that have .dvi as their extension. And the last thing I guess I'll point out is that ls is one of the Unix commands that lists things in the directory, but there are other commands. The ones that, of course, we're interested in are things like grep and fgrep and egrep, which these are basic pattern matching utilities that are going to use finite automata to actually match for those files. That's all under the hood. That's things that we've talked about before with DFAs and NFAs, but of course, today is about grep. Grep is the Unix text editor search command. It stands for Global Regular Expression Print. It's a standalone utility, and there are other so-called family members of grep, which include things like egrep and fgrep. Let's talk about the differences between egrep, fgrep, and grep. Grep uses regular expressions for pattern matching, as we've kind of talked about already. Fgrep is file grep. It does not use regular expressions. It only matches fixed strings, but you can get search strings from a file. And then finally, for us, we're going to use something called extended grep, which uses a more powerful set of regular expressions, but it does not support back reference, something called back referencing. And generally, egrep is the fastest grep family member. A lot of times grep and egrep are going to be more or less interchangeable for what you want to do. There is one more, which is called agrep. It is approximate grep, and it is not standard. All right, so let's start looking at things that grep can do with some examples. The first thing that you can do is match a literal substring. Basically, the string matches if it contains a substring. So I have here an example. This is a sample file, which I've named sample.txt. And it literally says this is a sample file. On the next line, it says hello world. And then it says on the next line, sample text for testing. So these are complete sentences. And if you have your terminal available, you should create a sample.txt file and then give it a shot and see what happens, ensuring you're in the right directory and everything. What happens if you do grep sample.txt? So it's grep space sample in quotes, and I have a lowercase s here, and sample.txt. If you gave this a shot, you should see that the result that it outputs is just this is a sample file. It just prints out that line because it is the line that has the word sample with a lowercase s on it. Good. All right, that's probably the simplest thing that you can match because you're just matching the exact letters. Now, we don't just want to match literal substrings, we want to match patterns. There are some reserved characters that are going to help with that pattern matching. Things like dot, like period, star, question mark, plus, open and close parentheses, open and close square brackets, open and close curly braces, forward slash, backslash, and pipe. And then another thing to point out here is that the context in which these characters are typed Some characters may have special meanings based on their position in the statement. The first special character I'm going to talk about is the one that lets you escape special characters. So as I just mentioned, things like star and question mark are special to grep, but you may want to match these literally. If you do, you're going to escape the character with a backslash. So here's the backslash character, which itself is a special character, and its power is to allow you to escape that character. Let me show you an example. Let's say you want to search for the literal character sequence A star, B star. Remember, A star, B star, if we're talking regular expressions, it normally means 0 or more copies of A and 0 or more copies of B. That's not what we want. So what we're going to do in order to get literally A star, B star is A backslash star, B backslash star to search for the exact string. And now star is treated as a regular character or a normal character instead of a special character. The dot allows you to match with any character, any single character. So let's look at an example with egrep. Let's say I have this file, and on different lines I have apple, banana, apricot, apex, orange, grape, and the phrase snap to it. And now I'm going to do egrep ap sample.text. So this file is called sample.txt. It's going to find lines that have ap on them. So banana and orange are going to disappear. But the other thing is I have 4 dots, which means I need to have at least 4 characters after the AP, which means apple is going to disappear and grape is going to disappear because even though they have AP in them, they don't have 4 characters after them. And so I'm left with apricot and snap to it because they have AP in them and then at least 4 characters following. The next special characters in regex are the square brackets. If you put characters inside the square brackets, it means only those characters. For example, if you have square brackets and I have the letters D, O, F, and capital Z, it matches only the letters D, O, F, and capital Z. If you have a string like dog, then D, O, F, Z will match D even though O is also in the class. This expression can be stated as match one of either D, O, F, or Z. Some more examples that are similar: capital A through Z and lowercase a through Z matches any letter. And then in brackets, lowercase a through F, capital A through F, and 0 through 9 is going to match any hexadecimal character. You do have to watch out in grep to use special flags if you want case insensitivity. So these won't work right away, but I'll leave you to wrangle with that later. The next example we'll look at is caret, in this case inside brackets. For example, let's say I have that file with the different fruits on it, and now I want to do egrep, and then you'll see that I have a caret inside brackets, A-E-I-O-U. And then another thing I've added here is this tr backslash n, and then just a string for a space. Now what's going to happen is it will, because of the caret in front of A-E-I-O-U, remove all the vowels, and also that tr with the backslash n and then the space inside the single quote prevents it from being new lines and then makes it so that it appears all on the same line. Good. Great. Now, caret is a little special. There's something called anchors. So this is full text matching with anchors, caret, and $sign. And so it turns out that the caret has another special meaning. It anchors to the front of the line. Meanwhile, $sign anchors to the end of the line. Let me show you what I mean. Let's say I have this file that has the names on it Dan, Danielle, Danny, John, and Daniel. And now what I'm going to do is say egrep and then caret Dan $ example.txt. What's going to happen is it's going to print out only the name Dan. So exactly one word is going to get outputted, which is exactly the name Dan. If you instead do egrep and then Dan in single quotes with nothing around it, then it's going to print out anything that has a subscript, substring Dan. So not just Dan, but Danielle, Danny, and Daniel. Of course, it'll skip John because it doesn't have the substring Dan in it. So this is another special meaning for anchor, and as well, we're talking about $ here. So one thing to be aware of is that whether you're inside square brackets or not can change the meaning of a regex. The next symbol is plus for one or more repetitions. For example, if you have the name, if you have the regex of snake as SNA plus KE, that will match the word snake, the word SNAAAAKE, so any number of A's more than one. But it will not match SNKE. There's another way to do counting, which is in curly braces. For now, I'll just point out that this is equivalent to one, in curly braces, 1 comma. The next special character I have is pipe, which gets used a lot, but we've seen this sort of before because it means that it matches one or another sub-expression. So this actually does go with what we've talked about before in theory. For example, if I have SNA and then in parentheses IL, pipe KE, that will match either snail or snake. Next, I'll talk about character ranges, which you will do inside square brackets. Inside a character set, you can specify a range of chars with the dash. So if I have square brackets, lowercase a-z, then it matches any lowercase letter. If I have a-z, lowercase, capital A-z, and then 0 through 9, then that's going to match any letter or digit. If you put a caret inside a character set, it negates it. We've seen this before. So if I have, for example, square brackets and then a caret A, B, C, D, it'll match any character except for A, B, C, or D. And if you want to match dash exactly, then you will need to escape it. So here I have inside square brackets \dash, which matches an optional dash or plus, and then followed by at least one digit. The next special character is question mark. For example, July question mark will match either JUL or JULY. And it's equivalent to curly braces 0, 1. And it's also equivalent to, in parentheses, JUL with the pipe alternator and then July. The next special character I have is star, which means 0 or more repetitions. This should look familiar because we've been talking about Cleany star for a little bit. Let's look at an example. Let's say I have this file that has color spelled the American way, then on the next line, color spelled the British way, and then on the next line, color with several U's, then just col, and then color with several O's, and then a UR. And let's say I do grep COLOU star R. If you run this, it's going to match any number of U's, including 0. So the words that get matched are going to be the top 3 in this case, because the first word color has 0 U's in it, so that works. The second one is color spelled the British way, so that works with 1 repetition, and the last one has several repetitions of U's. So again, we've talked about star before with Kleene star, and this looks very similar. The thing to keep in mind here is that star is going to bind to the thing that is to its left. One thing I've been showing you on different slides, but I haven't talked about what it means yet, is the curly brace. So if you do curly braces min comma max, it means between min and max occurrences. Min or max may be omitted to specify any number. For example, if you have 2 inside curly braces, specifically 2 comma inside curly braces, that means 2 or more. If I have inside curly braces comma 6, it means up to 6. And if I have 3 inside curly braces with nothing else, then that means exactly 3. Let's look at an example in a file. Let's say that I have this file hello, hello with 3 E's, hello with 3 E's and 3 O's, and hello with 2 E's and 3 O's. If I do egrep and then E to comma hello.txt, then this is going to give me all of the lines that have hello that have at least 2 E's, in them. So which lines get removed? You'll see it's just the first one. There are also built-in character ranges, meaning that instead of typing in square brackets 0-9, you could just do \lowercase d. Instead of typing in all of the white space characters like tab and new line and space, you can do \s and so on. So let's just look at an example. I know that these are a lot of codes. You're not going to remember all of them, but let's look at an example, which is \w plus \s plus \w plus is going to match 2 space separated words. Let's look at that example on a piece of text. So we're going to do egrep on \w plus \s plus \w plus apple, banana, apricot, apex, orange, grape, and snap to it. And what will happen is the only thing that's going to get printed out by this is snap to it, as it is the only thing that actually has 2 words separated by white space. The last thing that I have in this video for you is a sample text file that just shows a couple of different patterns that you might try to match. You might try to match sentences, you might try to match IP addresses, you might try to match URLs, you might try to match emails. All of those things have a certain pattern associated with them, but sometimes describing them is quite complex. So the last thing, either make a copy of this particular file that I have written, or just type up some random stuff on your own that has these sorts of things in them, and then give a try to those command line utilities that I had at the beginning. So I have grep-v and then this stuff with the backslashes and carets and a hashtag, egrep and this \d and the \w and dot inside brackets. And I have a sed command for you. So all of these things, give it a try with whatever files you want, just to see what it's going to end up printing out, because of course you'll get a better intuition of what's going on if you actually try it. And I will say, if you need to look any of this stuff up to know what these flags are, so I didn't really talk about these too much, -v, -o, -e, those are all things you can look up by looking at the man pages. All right, that's all I have for now. I didn't go over everything in Regex or in grep, but hopefully this gives you a good place to get started with pattern matching. Thanks for watching.